Okay, hello and welcome back. All right, yeah, we're getting close. Do I have anything more? No, actually, I don't. I just have some review stuff next week, unless suddenly I come up with something and say, hey, oh, by the way, we need to cover this. But I'm kind of not expecting it. All right, but in any case, so our final thing we're going to cover in this course is something about runtime exceptions and exception handling. This is actually really kind of critical things. Some people may look at this and go, oh, that's incredibly complex. And yeah, the concept of exception handling actually could be incredibly complex. And I still include it in here, not because I want to make things complex for you, but because by providing just a little bit of a context and some fairly easy context, it will help those who carry on to a course called Object-Oriented Programming, where you will be dealing with a lot of really difficult exceptions. And if you don't understand like simple little things we're doing today, it's going to make that seem incredibly overwhelming. So it goes along really well with the concept of files. Okay, so I might, in fact, I might go back and I might try making a small file to do something, and then we'll just see what happens. Okay, all right, so unfortunately I didn't come with a completely good prepared example, but I know what I want to do, so we'll build it as we go. Okay, here, let me close up this guy. And we'll start here in the slides first. Okay, so number one, okay, exception handling. Yes, there's a section. It is actually in the OpenStax book. All right, so here's a problem. Oh, that's not helpful to you, is it? It's a nice view for me, but not for you. All right, so we have a bunch of things called runtime errors. So what exactly are runtime errors? Well, these are things that occur while the program is running, as opposed to syntax errors, which happen before you even get started. So a syntax error is something that as soon as you try to run the program, it immediately says, oh, no, we're not even going to start that. Things like missing colons at the end of if statements, missing closing square brackets on indexing, all of these types of things are syntax errors. You don't get to go anywhere. Now, syntax errors are always really nice because basically your program doesn't start. And you'll say, that's not very nice. I want my program to start. No, actually, if you have a mistake in your program, you don't want it to start. And likewise, if you're using somebody else's program that has all kinds of bugs, you don't want that program to start either. Like, for example, and I used this concept or this example the other day, is imagine that there's a bug in Microsoft Word. When do you want to find out about that? Before you start using it, or just when you're about to hit save? Right away. Right? Because, I mean, if it doesn't work, it's just like, it might be frustrating, but it's not going to be nearly as frustrating as using Word for an hour, writing something, and then as you're about to save it, suddenly it crashes, and all of your work is lost. Nobody's very happy with that. So, runtime errors are those types of errors that happen while the program is running. Okay, they can have some real serious, devastating consequences to a program if they do happen. But of course, we're kind of used to it because, I mean, we'd be probably writing a whole bunch of things. Here, let me grab all of these and I'll actually execute these kind of one at a time, even though I know that we can already see the items here because, well, first of all, does the program even begin? Okay, well, just to let you know, here we go, starting. Okay, you see, the program starts. That's not the issue. But if I start to do things like I leave out this, like, okay, I've just removed the closing quotes here, you see, it doesn't even begin. Okay, because what happens is, as soon as you click on run, and it doesn't matter if it's this online editor or if it's idle or PyCharm or whatever, the entire file is given to the Python interpreter, who will then go through and make sure that there are no obvious problems. Okay, and we're talking about something that falls into an area called static code analysis, and these would be syntax rules. All right, and of course the issue is well, right now I'm missing a closing quote, and well, maybe the user meant this and they just accidentally hit enter. Okay, so this is why we need to have these things cleaned up first before we begin. So that's a syntax error. Now, on the other hand, when you start to deal with a runtime error, you have the case where the program begins, but then stops, well, partway through. I'm going to say immediately. And, of course, it will pop up and it will tell you the type of error that happened. It will always provide a nice description about where it happened. That's really important, by the way. And it'll also tell you exactly why it ended up failing. Now, unfortunately, what it doesn't tell you is it doesn't tell you how to fix the problem. Syntax errors, it's usually pretty clear because if you miss a terminating quotation mark, like for example, here, let's go back to this one. If I just leave this one out, on terminate a string literal. Okay, well, that means that I need to terminate the string literal. That, of course, requires that you know what a string literal is. Okay, as I talked about this at the beginning. At the same time, if you have any type of an error where everything stops, yeah, you have to be able to read the error messages. In fact, I suppose maybe what we should have is more questions like this. Here's an error, tell me where the problem is, or explain what the problem is. That would actually be really, really useful. In any case, the problem occurred on line number 3. Okay, that's fine. And what was the problem? Well, it says that the tuple object is not a support assignment. So even if we didn't see the error message, well, I mean, you should be able to still get a pretty good idea what's going on. And if you see the error, you go, oh, right, it's a tuple. Okay, well, just don't be silly, don't make the mistakes. You know, sometimes this happens. Okay, this type of thing happens to me. I think I've got a list, I'm trying to change it, but turns out it was actually a tuple because I didn't look closely at what the function returned. But you have to be able to look at these and you have to say, oh, right, we can't change it. I can make a brand new one. Okay, so that if you really wanted to change TV to be uppercase TV, you could make a brand new tuple, but that would require a change to your code. All right, well, here, let's get rid of the problem and see what's coming next. Okay, again, does the program begin? And yeah, the program begins, but then it ends up stopping. In this case, on line number 7, it came up and it said, hey, there was a key error. Well, that's because I've got a key called 3544 and 1134, but I don't have a key called 1100. Okay, that's fine. We've seen this before as well. Remember that these things show you exactly where they are. I mean, what are we supposed to do in the case that something goes wrong? Well, I don't know that yet, but we'll figure this out. Okay, we'll have to write a small program, and we'll talk about it. Okay, next one up. All right, this one right here, that's an invalid literal for an integer with base 10. Okay, so what have we got? Well, you see somebody got an input string and they accidentally typed 34.56. Okay, when we tried to turn it into an int, well, there's no such thing as a 0.56 at the end. That is a problem. Okay, all right, that's fine. That's once again a runtime error. And this one down here, same type of thing. We got the list indexes out of range. That's an index error. Okay, so all fairly simple things. Let's put together a small program to try and do something. Okay, because let me see what I've got on my slides coming up, because I bet I'm probably going to be doing exactly the same thing, but just out of just for variety, I may do some slightly different things. Okay, so this slide I don't mind. All right, now here's the problem with runtime errors. Okay, they could lead to tremendous frustration. You see, syntax errors, okay, it might be frustrating for you as a programmer, but really, these are the really nice ones because they usually tell you exactly what the issue is. On the other hand, runtime errors are very detrimental to the user, because if the user is doing something and the program is working away on some data and suddenly it stops working and it simply says, oops, sorry, key error, that's not very nice. Okay, because it means whatever they were in the middle of doing is probably now wrecked, especially if they're interacting or entering things. Okay, so let's see if we come up with some slightly better ways. Oh, now I know exactly what I want to do. Okay, so the problem is that the exceptions cause the program to terminate unless they are handled, whatever this means. So my comments, it was the same example I used last time. Hey, yeah, if you tried to do something in Word and you tried to type some word or some value and it caused your program to crash, this is not going to be very good. Okay, let me toss this aside and let me see what I've got as the example. If I don't have a good example, okay, it's not as good of an example as possible. So let's write today an infs 1101 program. Okay, yeah, this is infs 1101. Let's ask the user to enter a bunch of test scores. We'll calculate the average of the test scores, and we'll let the program stop when the user puts in -1. Seems all pretty reasonable. It's an 1101 problem. All right, so let's do this. You know, for this, what we're going to have to do is we have to calculate an average. Okay, so you know how to calculate an average. You sum everything up, divide by the number of items. We have a couple of different ways how we can do this. You can do this as a pure 1101 where you set up a loop and you keep adding to a sum, or, well, you know what we're doing today? we're going to stick it into a list because that's really kind of a 1201 approach. And what I'm going to do is I'm going to ask the user to put a bunch of numbers in, and what I'm going to do is I'm going to append them onto the score list, and then at the end I'm going to take the sum of scores divided by the length of scores. Okay, maybe we've got an odd case we have to deal with, like if there's no scores, but this is fine. Let's go for it. All right. Oh, the magic infinite loop. Okay, you don't like infinite loops? No problem. Come up with a condition afterwards. Here's what's going to happen. I need to ask for a test score. Okay, well, we're going to ask the user for it. Yeah, it's going to be different. So, of course, what I'm going to do is I'm going to say input, enter, test score. Okay, and all that I'm going to do is I'm going to go to scores and I'm going to append the score called test and down, oh, sorry, I better ask the following question. If test is equal to -1, what would you like me to do? Probably break, right? Get myself out. Okay, otherwise append it to the score, ask again, and just keep on going and going and going. At the end, I'm going to print the tests, the scores. All right, and what I should see is I should see all the scores. Okay, excellent. Let's give it a shot. All right, so enter a test score. Okay, 60. Oh, good, this is working so far. 80, 90, and 100. And if I put in a -1, well, of course, this will end up stopping. And then I should see the list with 60, 80, 190, 100. Oops. How come it didn't stop? Okay, sorry? I think so. Yeah, here. You know how you debug it? Print test. Right? What do we got? Is it working? What's happening? Okay, unfortunately. Okay, there we go. Takes a little time. All right, 56. Yeah, that's a 56. 70, no problem. -1 is -1. How come it didn't stop? Okay. Yeah, there you go. I was about to say, maybe you'd also like to print this out. There's my debugging tip for the semester. In Python, if you are trying to figure out what's going on and you don't have a proper IDE with a debugger, which we don't here, sorry, I mean, it would be great if we had one, but we don't. So this is your debugging technique, is print out the value to see what you've got. It's also not a bad idea to print out the type of thing that you have. Okay, and here, I'll put this into a context. I watched somebody yesterday in our lab 7, and so this is in my other section, so they're not here, so we're not making fun of them. It's a legitimate thing. The student was trying to say for something in something.items. That makes a lot of sense because of what we do. Unfortunately, the thing they were trying to apply .items to was a list. Yeah, and they don't have a .items. If they had simply printed it out and said, okay, what's inside this and what type is it, you tend to learn very, very quickly what it is. Like, for example, oh, yeah, that's a string. So the -1 is actually a string, and as a result, yeah, it's never actually going to be equal to the value -1. It would be equal to the string -1. In fact, I am going to do that right now. Okay, here we go, and 78, 90, and I'll put a -1, and it does stop everything, but I bet you don't like that list of strings because, well, they're strings and you can't do any calculations with it. All right, so solution to fix it. How do we fix it? And int after the test. Okay, so there's a couple of places where I can put it. I could either put it here and cast it as it comes in, or I could put it right here, casting it after we've got your choice. But if I cast it before, then of course, well, now it's an actual integer. So do I do it in both? It's kind of overkill. So your choice. But you know what? From 1101, we probably did stuff like this. And that's fine enough because, I mean, the test really is an int. All right, so yeah, okay, perfect. So this is going to be much, much better. Okay, so 60, 70, sorry, ignore that, pretend you didn't see it. All right, 67, 87, 90, and of course a -1. Yeah, now we've got it, okay? And yes, we can see that they're integers in every case. So now we can remove this problem. You know what, I'm gonna leave it here. I'm gonna leave it here because this will be part of my demonstration. All right, now, I would like to make a mistake, okay? And actually, you just saw it a few seconds ago. 78, 67.8. Yeah, this is a float. What's going to happen when I run this? Okay, I'm not going to press enter until somebody takes a guess. What's going to happen? Is it going to truncate it to just store the number 67 or what?
Should be an error.
Yeah, an error. The program is running, so therefore it's a runtime error. The runtime error is a value error, and it's showing up as an invalid literal for an int because somebody typed 67.8. I mean, you've seen, I just made the mistake and I accidentally hit a backslash instead of pressing an enter key. All right, so yeah, that's exactly it. Now, this is fine because, well, the user just has to put in the number and then put in the next number. Not a big problem. What if the user just typed in 150 numbers? That's pretty irritating, isn't it? Go back and type them all again. Yeah, maybe what we could do is to come up with some kind of a mechanism that would prevent this whole program from halting completely. And that's the type of thing that we're talking about today. This is called exception handling. So whenever a runtime error occurs, what happens is Python generates something called an exception. Exceptions cause the entire program to come to a screeching halt, which it does, and it will describe exactly on which line it was on when the exception occurred. So it occurred on line number 3, and it will provide as much information as it can in order to explain what it found was wrong. Okay, maybe it's an out of bounds index array, maybe it's a key error, maybe it's a divide by 0, that's always the typical one we talk about. Maybe it's one of these value errors because this happens all the time. And you'll say, yeah, just, well, teach people to not type in bad numbers. Yeah, that's a really good idea. We could solve this problem a little bit by loading the data from a file, but guess what? There's nothing stopping the file from having the same problem. Okay, so it could actually have the same issues. All right, so what we're going to do is we're going to introduce a mechanism, which is really quite clever, about how we're going to deal with that error. Now, the first thing that we have to ask before we start to do any correction in here is I'm going to ask you, what would you like us to do if somebody types a bad input? You see, you have the option of completely stopping. Maybe not showing this message, but say, yeah, your inputs are invalid, I'm not doing it. That's one approach. Another approach is, yeah, just let them try it again. Let them try it again. That's probably one of the nicer approaches. Now, in 1101, I know they do some input validation, but it's some very, very strange ways how they do it because, well, we're certainly not going to cover exception handling in 1101. The usual thing that you would do is, well, guess what? If I make it a string, that's easy. There's no question what's going to happen. I can type this, it's never going to give me an issue. I can type -1, I can type blah, 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 blah. It'll never have a problem. The problem, of course, will appear is when it gets put into the int of array, or sorry, the array, sorry, wrong course, the list of integers. Okay, if I ever say array, I mean list, it's the same thing. All right, so it'll always go in there, but of course the problem is that you want these to be integers, so you need to have the typecasting somewhere. The real issue is that it happens right here in the middle of the loop, and of course this causes everything to stop. Okay, how do we solve this problem? Okay, well, what we're going to do is we're going to introduce something new. Okay, it's kind of a clever idea, and here's the problem. You see, the following piece of code, we hope it works. I mean, that's literally what we're saying is, oh, please, 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 please work. Okay, I mean, that's really what we're saying is, please let there not be any problems in any of the code that I just wrote. I mean, this is, well, of course, what we always say, but if you want to let the program to continue to execute, okay, take a look at this. I got a new word for you. It's called try. Okay, so it's, please try the following stuff. Okay, what stuff would you like me to try? Well, I want you to try all of this, okay? Not just the input, but I want you to try everything. Okay, because if it works, we would normally take the input, we would check and see if it's -1 and break, and we would append it. That's it. That's the good case. Okay, so it says, please try the following things. All right. Well, what if it doesn't work? Okay. What we have is we have another area called an except. It looks kind of like an else if, or an if-else. And yeah, it's actually pretty similar to this. What would you like me to do if something goes wrong? Well, how about I just say, problem with input. But you're exactly right. Maybe please enter another value. Okay, yeah, that would be probably even a more appropriate message. All right, so you can think about this as being kind of this really strange if statement that says, okay, give the following stuff a shot. If it works, excellent. Ignore the except area. If anything goes wrong ever inside any of these lines, go to that. Okay, so which line is likely to give you problems? It's going to be line number 4. 4 is going to be the trouble. Okay, checking to see if test is equal to -1, that never fails. Printing things, that never fails. Does appending ever fail? And the answer is no, it doesn't. An append will always work. I could have done something else like a find, and of course that would fail if we were missing a key. But really in this case it was only line number 4. So you might say, well, why don't we just try line number 4? Well, because if it works, I want to do the append, and if it doesn't work, I don't want to bother looking at a -1. I don't want to bother looking at printing a problem message. It literally is just please skip the rest of it. So here's the process. When I run this, so here, we'll start this one up. When I put in a number like this is not a problem. This is happy case. Okay, which line number is my program currently on? This is not a trick question. Yeah, it's number 4. It's the input statement. The try has nothing to do with it. Okay, so yeah, if you were tracing this through on paper, you'd say, okay, it goes to line number 1, it goes to line number 2, it goes to line number 3 or 4. It doesn't really matter, but the try really has nothing to do with it other than to say, this is the block I want you to try. This is not going to have a problem. So here's the process about how this is going to work. When I press enter, what's going to happen is after line number 4 comes line number 5. I'm going to print the values. After line number 5 comes line number 6. I'm going to ask the question, is it a -1? It isn't. So I'm not going to do the break. Instead, I'm going to come down to line number 8, and I'm going to do the append, just like what we had before. And then what comes next? Well, what comes next is I go back up to the top of the loop on line number 2, and I do the whole thing again. Okay? Because that except block only happens when things go wrong. Okay? Nothing goes wrong. The except block is never looked at. All right, so let's press enter and see whether or not, I don't know because we're not going to be able to see the memory, but it certainly hasn't crashed. And you'll see I've come back up to the same place. All right, let's do another one, a 50. It's also not a problem. And you know what, just for a -1, before we start introducing issues, we put a -1. What would happen is I'd end up on line number 5 that prints it. I would get to line number 6. Yes, it is -1. I would then do a break. The break, of course, refers to the loop, not to the try block. And then I come down to the print scores and I continue on with, well, whatever else is in the program. Okay? So everything is fine. So if I come over here and press enter, this is the program. Now I can do my calculations by adding up everything and dividing by the number of items in the list, and I've got myself an average. Okay, now let's try some real stuff. Okay, 2 values went in without an issue. Whoops, I accidentally hit some random characters. All right, here's what happens when I press enter. Remember, I'm currently on line number 4. I press enter. Now, normally you say, yeah, but you go to line number 5. You don't in this case because this function right here, the int, this fails. This is a runtime error. This causes everything to stop. Okay? Causes everything to stop. If there was no try and except, the whole program comes to a crash and it says there was a value error on line number 4. But because I have put it inside a try block with an except, instead of crashing the entire program, the program will immediately jump down to line number 10, print the message, but then the program continues. Well, remember the except block, this is still inside the loop, so I go back up to the top loop and I do the whole thing again. So the result is, over here when I press enter, yeah, there's a problem with the input. I haven't caused a crash, but without that try except, different language. Other ones use this thing called try catch, but try and except, without the try and except, the program would be finished. And that, as I said, would become really disastrous if you were working on a really big program and somebody has just typed in a whole pile of test scores and they accidentally do that. instead of crashing the entire program, at least now we can let it continue. This is the whole reason why these are here. The -1 still works the same way. Sorry, it's just gone off the edge. And now I've got all of the data that I need. Now we can go through, we can do our calculations for the average of all the test scores. It's a pretty neat concept, but yeah, it's one extra thing. Now, in the case of what I just put here, let me remove this for a second because I kind of solved this in a bit of a more general case. Let me just remove this for a second. Oh, yeah.
Do we have to, like, I'm not sure if this question makes sense, but do we have to have try and accept at the same time, or could we, like, if there is try but someone forgot to put accept?
Okay, you know what? That's a reasonable thing. I will demonstrate that. Okay. Let me go back to this one for a second. So there's no errors. Okay, and of course, so I have no try and accept right now. If I press enter, what's going to happen? Yeah, it's the crash from before. Take a look at the type of error that came back. It's called a value error. Okay, let me undo everything. Now the official. Oops. Okay, I'll just say bad input. The official thing that I should have been doing was I should have said accept value error. So this is what happens when you get a value error. You can actually have different types of errors, like you have key errors and so on, and you can have different accepts for different types. It's a little bit beyond what I want to cover in this course, but it is here. This will still work the exact same way. Okay, here you go with a -1. It still will pick up the first two values, just to be so that I'm consistent with what I've got here. All right. So now the question was, what happens if I put a try without an accept? Yeah, I think this is the question. Yeah. Okay. There you go. It's a syntax error. Okay, because you can't have a try without an accept. Okay, so that is one of the issues. Without an accept, yeah, it is a syntax error. In fact. Okay, well, it is a syntax error, so yeah, I can't catch a syntax error because the program doesn't even run. Okay, so that's good. At least it's kind of consistent. All right, let's go back and take a look at what I've got here in the next slide. So here is one example. Okay, so same idea as what I just did. In this case, what the user has attempted to do was they have a string, and they went and they said, okay, s at position 0 is equal to h. It's the usual string immutability problem. And of course, well, the string was changed, or it came up and it said that there's a problem with that operation. The rest of the program, by the way, continues. The program doesn't crash. We simply jump to the accept handler, we handle it, and we let the program continue. Okay? This is really kind of the main part that I wanted to cover in this. I'm not going to ask you in the final exam to write any exception handling code. However, being able to trace a small program like an MCQ about what will happen, I think that's legit. Okay, that is completely legit. But I won't get you to write it, because we don't have labs for it. All right, next one up. Now, as an interesting thing, let's try this one right here. Compute the average. Okay, good. We have a bunch of data. Okay, so here, let's write this in a function because this is actually kind of cool. All right, so. Okay, print average scores, def, average, okay, and what we do is we take a bunch of data. Okay, remember we need two things. We need the sum, okay, so we'll have it called total. How do I calculate the total of a list full of numbers? Sum. Okay, and of course we need the num else, number of elements. How do I get that? Yeah, length of data. And then of course the average, AVG, is equal to the total divided by the num else. Yeah, I really don't need all these variables, but I am doing it on purpose. And of course what do I do with the AVG? At the end I return it, AVG. All right, so you go and you run it, you say 73.8. Okay, yeah, pretty decent. All right, let's start causing some problems. Okay, what kind of problems can I have? I think that's a problem. Okay, what's going to happen here? Well, nothing good. Okay, Is it going to be okay? So let's make the prediction. Okay, so this would be this would actually make a decent final exam trace question. On which line do we have an error? And none of the above is one of the options. Okay, so it could be on line 8. That would be a good option to put as a distractor, or one of the options. I might say line 2. I might say line 3. I might say line 4, and I might say none of the above because the program doesn't crash.
Line 2, because you can't sum a string.
Good, that's exactly it. Oh, it is a runtime error. The program will begin. If you don't believe me that the program actually runs, I'll just put the word starting here to know that it's actually going. If we see the word starting, we know the program's running. Yeah, it's a runtime error, not a syntax error. All right, this is a type error because you're not allowed to have strings and ints in the same list where you can use this. Now, of course, what I could do is, okay, here we go. We flip it around. Sorry, Control X. Okay, here we go. Paste. Okay, here we go. All right, so now, of course, the problem ends up on line number 3, just because I flipped it around. Okay, that's fine. There's nothing tricky about this. All right, so yeah, we got a function that has problems. Ooh, okay. What can we do to prevent the problems? Try and accept. Now, the question is where do I put it? Now, your initial reaction is going to be, yeah, I'm going to put this in a try and accept. And I'm going to show you something really, really cool. We know where the problem comes from. We know that it comes from the average function on line number 3 is the current issue. Watch this. This is really, really neat. Try. Accept. Okay. Hey, wait a minute. But I don't have the problem in here. Yes, but the code I'm calling has the problem. And this is really cool because this actually triggers. So here's the flow. Here's the flow about how this works. All right, we have to trace it. Sorry, it's an 1101 thing. So where do we begin? Okay, well, we always begin on line number 8. Okay, line number 8 defines a list of scores. Yeah, it's got a P inside, that's fine. It will then go to line number 10, which prints starting. I will then end up coming inside line number 12. But of course, line number 12 is a call to a function called average. So I jump up to line number 1. Data, of course, is scores. I come to line number 2 and I say, okay, how many elements are in my data? 5, yeah. That doesn't have a problem. All right, so this goes on. And then I try to add up everything inside. And of course, well, this is now a problem. All right, at this point here, everything is gone. Does line number 4 happen? And the answer is no, it doesn't. Because if we were to remove this try and catch and just pretend that it never existed, you know what ends up going on is that the program will crash and it will point at line number 3 and it says, there is a problem on this line. And no, it never actually continues, okay? You know what, just for fun, I'm going to put something in here. Num elements found and print total computed, okay? We'll run this. Okay, so here we go. Run this one. See this? The number of elements was found. That part ran, but then when we hit line number 4, that caused a runtime exception. Everything else in the rest of the function was like, yeah, forget it. There's nothing I can do. Start crashing. But what happens is, yeah, we ended up jumping outside here because once we returned from the crashy function, it realized that there was an issue, so it said problem detected.
So, but except you don't always have to specify the error type?
Yeah, that's right. If you leave the error type out, it'll catch any type of exception. It's a very, very handy tool. Okay. It's kind of the lazy approach, but for this course, it's completely fine. Okay, it's completely fine for the context of this course. All right, let me see what's coming up next because I've got an idea what I want to do. Okay, I've already done that. I don't know that I want to do this. I think I might drop that one, but I will show you the slide at the end just in case. Don't worry, I'm not going to ask questions about the very last slide. No, I'm pretty sure I haven't. I will double check and make sure. But it might explain something that you saw in one of the labs, which I've been trying to clean up. All right. Let's suppose we didn't have exceptions, okay? I'm gonna give you a solution. How are we doing for time? Yeah, we're actually pretty good for time. Yeah, we got lots of time for this. I'm going to show you what we used to do in the old days. I hate to say that, but anyway, back in languages where we didn't have exception handling, because this is actually really quite cool, and it didn't always exist. All right, here's what I would have done. Okay, first of all, we know that this is an issue. Okay, we know that there's an issue in here. Okay, without the issue, it's not a problem. You just go through and add everything up. So let's do it this way. Instead of having prints and so on, okay, here's what I'm going to do. I'm going to have a total, and I'm going to say 4. Okay, what should I do? Yeah, that's fine. Okay, for the score and data, total goes up by S, and let's call it the, okay, this will be fine. And what I'm going to do is AVG is going to be equal to the total divided by the length of the data. Now, I suppose I could count it up because maybe we couldn't do that either. All right, I think this would be good enough. Let me do a quick little check in here. No, and I said no try and accepts. We just want something really, really simple because I said what we do before. Okay, good. So we're back as what it was, but what happens is somebody says P for pass, yeah, it's still the same problem. Okay, it's almost exactly the same problem because we're now just, instead of using the sum, now we've got this. All right, here's what I want to do. Okay, got a few different options about how I can deal with these inputs. Okay, now, first one up. So, how are we going to figure this one out? All right, here's what I want to do. That's really what I want to do. But how do we know if something's an integer? Okay, well, remember we have something called a type. Okay, I'm going to try something, and if I can't solve it, you know, I'm going to turn to the internet. Okay, maybe you'll use ChatGPT to solve it. Hey, that's what we use ChatGPT for, but we ask it very specific things. Okay, let's see if I can solve this without. Now, this is the problem because I didn't come in and I didn't try it beforehand. Can you figure out what type something is? Yeah, it's called type. Okay, so what I'm kind of curious is, can I ask this? Toop? Okay, I don't know whether or not this works. Okay, this is not asking you the question, this is asking myself, like, I don't know. All right, well, let's find out, does it crash? Okay, it doesn't. Unfortunately, it also gives a complete value of 0, so I don't think this is probably a good option. Okay, all right, so here's what we'll do. We'll turn to the internet, and let's ask this. Python, how to determine if a variable is an int. Okay. So what is it suggesting? Yeah, Copilot search. Okay, it'll probably generate something. All right, is instance. Okay, not part of the course, don't worry. Okay, I mean, if I don't know, obviously I can't expect you to know. All right, so it's something called is instance. Okay, that seems pretty reasonable. You can basically ask an if statement. Okay, and what we'll do is we'll set it right here. So we want to know if S is an int. Okay, and it returns true or false. Let's see. I think we got it. Okay, that's the sum. Well, sorry, the average. I suppose what we could do to really make sure is if we make everything a 78. Oh, we have a problem. Because if everything else is 78 and that P is there, the average should still be 78. Why do I have an issue? Well, because I've counted the P. Because I used length. Okay, so what we're going to have is we're going to have to say maybe valid, and I'm going to say that valid goes up by 1 each time, and instead of asking for the length of data, I'll say valid. Okay, there we go. Now it's a 78. Congratulations. Now, this is one thing. I call it the ostrich approach. You know what an ostrich does? He gets scared, he sticks his head in the sand and hopes that everything goes away. That's basically what we've done right here, is we've said, oh, okay, I'm going to give you something different, something completely different, and it goes along with the video I'm going to show in a few minutes. Not that I ever show too many videos, but this video is actually kind of cool, and I've actually seen the same type of thing happen. Okay, old days. Okay, first of all, there's a problem. Okay, Do we continue? Well, we could just completely ignore it and hope for the best. So invalid inputs, we just ignore. But maybe it would make more sense if we could tell the person who called us that there was a problem. Now, old languages, C is exactly what comes to mind. It's a C programming language. You see, you guys are really spoiling the world of Python because a Python function can return anything it wants. It can return a none, and it can return a list, and sometimes it can return a string. It's entirely up to you. In these old languages like C, you would have a function and it would return something. A function like this would definitely return a float. It's a real number. It would definitely return a float. Okay, so you have no choice. You can't return none. You have to return something. So often what we would end up doing is we'd be trained to say, okay, if something goes wrong, get out of the function, but send back something to let the person know something bad happened. -1 is like one of the most common things. Because is it ever possible to have an average of -1? No, of course not. All right, so there you go. You try running the program -1. Now you can modify your program down here and say if the result comes back as -1, now you can put an if statement to say, oh, hey, maybe there's an issue with the input. So let's call it right down here. I'll call it RC4, return code or result code. This is what I used to use all the time. And you say if RC is equal to -1, then you print that there was an error. Okay, and else print, well, we'd print the actual result code, I guess. So yeah, there's an error. Otherwise, you print the actual average and say the average was this number. All right, everything works perfectly fine until some programmer comes along and accidentally forgets to put the if statement in. So you got a function that's returning a -1, and instead of actually like stopping the program or alerting the user, you just let the program continue now with invalid data. Okay, I saw this happen. I wish I could provide the details on it. It was really quite disturbing what I ended up seeing. It happened to the company I used to work for, but it's one of these things where I said, yeah, I wouldn't tell people about some of these issues. This is one of them. I really wish I could, but I've seen this cause lots of trouble because if somebody now takes RC as the actual average and goes on and does a whole bunch of other things, you could end up with a whole pile of issues. Okay, so for example, if we're talking about test scores, maybe this is going to be run by the HOD who's going to look and is going to figure out, okay, what's the average class score for this particular semester. And if you end up with a student, okay, here you go. This is a code that shows up, AB. It means it was absent for the exam. This is when people are sick during a final exam and they have an excuse. This is going to cause you problems. And of course, if it comes back and says, yeah, the average score is -1. Well, if the average score is -1, maybe the entire class fails. Maybe the class is canceled. Who knows what's going to happen, right? So you don't want this to go on. And this is the problem about returning magic values. The exceptions are much nicer because the exceptions actually say, hey, well, we got a problem. And if you don't handle them, the entire program stops, as opposed to using the value and doing something completely wrong. Okay, so over here, got a little video. It's always my favorite video. Whenever I talk about exception handling, I really like this one. Okay, I always show this one because it's kind of cool. I think the audio will work today.
It's the 4th of June 1996, and the European Space Agency is launching its brand new Ariane 5 rocket for the first time. This is a big deal. The Ariane 5 is designed to carry large, expensive scientific and commercial payloads into space and heralds a brand new era for the ESA. A decade of design and testing and billions of euros have led up to this day. The Ariane 5 rocket carries no astronauts. The first payload is 4 very expensive scientific satellites to be delivered into orbit. Things start well. The rocket clears the tower and accelerates smoothly. And then the rocket abruptly changes direction, starts to break apart, and suddenly explodes. Less than a minute after launch, huge chunks and glowing fragments of Ariane Flight 501 rain down over the launch area. A shocking disaster for Ariane and the ESA. The cause? A simple, utterly avoidable coding bug. Okay, here's what happened. The Ariane 5 leaves the launch pad and accelerates smoothly into the sky, following its predetermined path towards space. Inside, the onboard guidance system is constantly tracking the rocket's trajectory and sending the data over to the main flight computer. To do so, the guidance system converts the velocity readings from 64-bit floating point to 16-bit integer. Okay, stop for a second and let's think about what that actually means. Computers store numbers in a variety of ways. Consider 4-bit integers. 4 bits can represent anything from 0 to 15. But if you want to represent the number 16, well, there just aren't enough bits, are there? 16's too big. You need more bits to store bigger integers. With 16 bits, you can store anything from 0 to 65,535. Or, if you throw in a sign, then 16-bit signed integers cover everything from minus 32,768 to positive 32,767. But anything bigger than that, and again, you've run out of bits. Floating point numbers are stored a bit differently. They're stored as a decimal, or significand, and an exponent. The details aren't really important here. All you need to know is that 64-bit floating point can store much larger numbers than can fit into a 16-bit integer. So converting between them can be tricky when the integer runs out of bits. So what does happen when you run out of bits? Well, if you're using 16-bit signed integers, the conversion will just wrap around to the beginning again. But whatever the details, you're definitely getting the wrong answer. This is known as an integer overflow. Right, so back to our rocket. The guidance system reads the horizontal velocity data of the rocket as 64-bit floating point and tries to convert that into a 16-bit integer to send over to the main flight computer. But at that moment, the velocity reading is actually larger than the largest possible 16-bit integer. The system tries to do the conversion and fails. Now, a clever system would have some procedure built in that says, hang on, we're piloting a rocket here. I need to say something sensible to the main computer. It would have some overflow error handling code. But in this case, the guidance system code isn't very clever. So it just sends an error message in place of the velocity data and promptly shuts down. Fortunately, there's a backup guidance system in case the primary module breaks down. Unfortunately, it's running the same code, so it does the same conversion, gets the same overflow, and crashes for the same reason. The main computer receives the error message, and because there's no handling code built in, the computer interprets the message as real navigational data and immediately freaks out. The velocity reading is off the charts, indicating that the rocket is dangerously, impossibly off course. So the flight computer does what it's designed to do. It fires up the boosters and drags the rocket around in an attempt to rescue itself from a non-existent disaster. This puts the fuselage under incredible aerodynamic strain, which starts tearing the rocket apart. Detecting that things are now really going badly, the computer calls it a day and triggers the built-in self-destruct mechanism. So, what was the ultimate cause of this incredibly expensive, very short, and ultimately catastrophic rocket flight? A simple line of code, converting a floating point to an integer that led to an overflow, passed without warning to the main computer, which was interpreted as real, if wildly inaccurate, data. The flight software had been used previously with no problems on many flights of the smaller Ariane 4 rockets, but the Ariane 5 was designed to fly faster than anyone planned for when the software was originally written, and the higher velocity led to the overflow error, a flaw that should have been found, it just never came up. Want to know the worst bit? That buggy bit of code wasn't even necessary during flight. It was part of the launch pad alignment process and shouldn't have been running after liftoff. But sometimes, a small glitch somewhere causes a launch to be delayed by a few seconds. So to save having to reset the system, the original programmers decided to keep that bit of code running for 40 seconds after the scheduled liftoff time.
Okay, so there's an example of what could happen if you don't handle your exceptions correct. I think that mistake cost somebody $5 billion. So pretty bad for an if statement, right? The one that I saw back in my company wasn't that much. It was worth a few $1,000s, but it wasn't quite catastrophic like this. But it did actually cause some money to be lost. The difference, of course, it's exactly what I just said. We have the two systems. One system, instead of actually like sending some kind of a proper error message to say this is what's going on, you need to handle this. What do they call it? The guidance computer was basically sending over an error message of -1, and the trajectory control computer was looking at -1 saying, oh, okay, that's what you want. And it said, okay, to fix this problem, I'm going to have to do this. And that's why it went wildly off course. And, well, once the rocket starts going off course, it's better to blow it up than to let it go, like, towards somebody. So there you go. There's sort of like the worst possible case of not having exceptions. All right. So the important thing here to remember, okay, so for today's exercise or for the course here, okay, so no, you won't have to write any rocket trajectory code for the final exam. You won't have to write anything that handles exceptions for the final exam. Everything will be kept in nice and clean format. So in other words, if I gave you a bunch of these things, well, I suppose I could ask this because that is almost an 1101 question. But you'd have to know how to do it in his instance. We haven't done it, so don't worry. I'm not going to suddenly get that as an idea. It can't actually do something you've never seen before. However, being able to trace one of these problems out, like for example, if I asked you the following question, oh, not like that. Here we go. Okay. There we go. Do we see the word A? Yes or no? Oh, and by the way, we don't have any exception handling anymore, so maybe I should go back to the exception handling, because this isn't even a problem with exceptions. Okay, let me undo this. Okay, come on. Back to a try and accept. There we go. All right, so here we are. Okay, print A. Down here, print B. And I would definitely print a C, and I would definitely do a print D, and maybe just for fun, I'd also do a print E. All right, now I suppose what I could do is I could say, okay, which of the following things get displayed? And it could be multi-select, like for example, okay, do we see an A, do we see a B, do we see a C, do we see a D, and do we see an E? Okay, what do we see? A, B, C, D. Okay, let's work it out in the exact order. Okay. Okay, well, maybe not. But remember, the very first line would be C. Do we see it? Yeah, no problem. Jump inside. Yeah, this is not an issue. Do I get through my loop without a problem? In this case, yes, because all the data is valid, so therefore I will see a B, and then, of course, I will see a D. Will I ever see the E? No. But, you know, I could certainly put an extra one down here. Will you see the F? And the answer is yeah, so we will get this. So that's the C, A, B, D, and F in that particular order. All right, now let's modify this a little bit. Okay, that's a problem. Okay, what do we see this time? Okay, so let's start asking questions, kind of one at a time. First of all, I'm going to ask, okay, we'll just go from A to B. All right, do we see an A? Yeah, we see an A because when the program starts, we don't have an issue until after the average function has started. So the A will definitely show up. Do we see a B? No, this is going to be the problem because what's going to happen is that there's going to be a crash on this line as I'm going through and I try to add these things together. Okay, that's going to be the problem. So as a result, if that generates a runtime exception, it's finished. But because I have a handler, I'm going to see E. Okay. Will I ever see D? And the answer is I will never get there because the exception handler would have picked it up. And will I see the F? Yes, because the program continues. The program continues until completion. It's only going to be picked up for the except. That's it. Okay. The rest of the program does continue. Okay. Okay. So I start by showing C. That's no problem. I make the call to the function. I jump up to here. This shows up without an issue. I then jump into this loop where I've got a total. Now I'm going to iterate through, but of course what's going to happen is I'm going to add a 78, then a 67, and then a Well, as the video said, what? Okay, that's going to be the problem. At this point, you're finished. Sorry, the function is finished. The program is now kind of in, I'm going to call it crashing mode. It hasn't crashed yet. If there was no exception handler, it's done. But because there's an exception handler, what I do is I jump out to the exception handler that I set when I call the function. So I would show the E. I do whatever's inside the except block, and I continue with the rest of the program. So that's why the F also shows up. Okay, so I suppose the questions could show up something like this. Okay, so it's basically some tracing stuff. So no, I'm not going to get you to write this stuff, but being able to understand, yeah, this is what happens. Okay, that's what I'm looking for in this course, because you can already see that, oh, this has kind of got some weird flow to it. Yeah, if for those carrying on the OOP course, this gets really big. Like, because we're talking about being able to make our own types of exceptions as well. It's much, much more complicated than this. And I thought, okay, in 1201, this would be good to at least understand this is how it works. I use this all the time. Sometimes I show you these big programs. Sometimes what I'm doing is I'm reading like piles and piles and piles of data out of huge spreadsheets. Sometimes I've got like 2 or 3 million lines of data in a spreadsheet, and I'm trying to do something. Every now and then, somebody has mistyped something in the spreadsheet. So what do? Just stop? No. What I do is I set up an exception handler and I say, okay, if I got a bad line, just ignore it. I report it to say there was a bad line, or there's a bad item on line number 25, or 5,400,000, whatever, so I can go back and look at it later, but I still continue because sometimes I want to see the rest of the data even if I do have one mistake somewhere. Okay, so yeah, and then I can go and find out what the problem was and maybe fix the problem or fix the code so there is no issue. But it's certainly better than just like, yeah, it crashed, sorry, thank you. Because now I've lost all the data. And that's important if some of the processes I run, say, take like an hour to do. And some of the programs that I run really do take hours because it needs to pull a bunch of data and it needs to do a bunch of analysis on it. So having a program that's run for an hour and crashes when you are one line to the end, that's just like the rocket blowing up at the last second. All right, so there we go. That is that's the material for the course. Okay, next week, what I will do, I won't say for certain yet, but okay, definitely on Monday, we'll pop in, we'll do a quick little review. I have a feeling that the courses next week will probably be really short. If you have things that you want me to review, send me an email and say, hey, can you please cover this? Otherwise, what I will do is I may pick 1 or 2 things that I know that people have issues with. Maybe I will solve a couple of questions from the lab exam, especially ones that people didn't do well on. And no, I won't be providing any practice final exams. Sorry, we don't do this type of thing. But what I can do is maybe I can give you some ideas of some stuff to go off and try. Okay? All right, so that'll be next week. See you then.